I don't know if the audio works on your side or not. You can try to speak and see if I can hear you. Uh, the I report this problem to Blackboard, and I don't know if they have fixed it or not. Um, if you have any more questions or anything, want to talk with me, you can also discuss after the class if you want, and you can also call my phone if you want. Since we might have a little problem with well, audio on your side if they have not fixed it. So before we go through anything today, I would like to talk about two things. First, we're gonna have the first test on next Friday, okay, from 3 to 3:50. So that's the exact class time. You're gonna see the test at 3, and it ends and disappears at 3:50. So I'm thinking to give about 30 problems maybe. It covers section 1, 2, 3, and 5. I don't know if we did 1.4 or not, but double check it. Everything up to 1.5, including 1.5. Okay. So basically, the first chapter. That's about the test. So get ready for the test. Do a little review and try to practice a little bit. So what you do is you review the slides, especially and they go through the examples. Make sure you know how to do the examples without without looking at the answers. Okay, just do it by yourself, scratch. Don't look at the answer. And if you can work out the problems entirely by yourself, and you got the right answer, then it should not be a problem for you for the test. And as I said before, we meet every other class. So we're not going to have class on Monday. We do have class on Wednesday, but I'm not going to cover any new material on Wednesday. Instead, I just answer questions from your side, from you. If you have any questions, you need to put the test. Uh, just ask me questions if you got any on Wednesday, okay? And then on Friday you just take a test. So I just saw a little issue with my internet connection. Can you still hear me? Can everybody still hear me? Okay, great. All right. I do want to make sure this is working because I may not be able to hear you. I mean, you can try to speak as if it works. So that's about test. Okay, and the other thing is, you already got. I think everybody should get the Cengage code I sent yesterday. If not, just contact me. But I sent it to everybody. Okay. So what you need to do is just use the code, and then I think you already got a account in Cengage, so you probably don't need to create another account. All right. So some information I posted yesterday or sent an email may not be clear. If you already have an account, then you probably don't need to create one. If you did not you did not use WorkSign before, you didn't do anything, you don't have an account in Cengage, then you need to create an account using the access code, the Cengage code, Cengage Unlimited code. But if you already have one, then I don't think you need to create one. But you do need to, use that code to continue to use Cengage and WebAssign. And if you don't know how to do that, what you need to do? I posted the office hours of Mr. Michael Hawks in Cengage. He got office hours every day from 2 to 4 and next week, except for Wednesday. And so I send the link to you. You can reserve the office hours and ask him for help. Okay, for that part. But you do need to fix that thing because you're going to take the test on Friday. If you don't use the code and make it work, then you will not be able to access website to take the test because the grace period expires this week. All right, so you do need to use the code to get it work. Of course, if you already bought one before, then you don't have to use this one. Just leave it there, and you can use the next semester. Okay, so you don't waste anything. Okay, so any questions about anything so far? I guess that's what I want to say to start. Reggie, I cannot hear you. Are you talking about something? Can you tap? If not have any questions, then I will start the lessons. Okay. So basically, we have finished the chapter 1. So we're going to start chapter 2 today. As I said, I'm not going to go through and go over any or go through any material on next Wednesday, which is the only day we have class. On Friday you just take the test by yourself, just like you do the quizzes from 3 to 3:50. All right. Let me share the slides for this chapter 2. Okay, section 1. All right, so we're going to start a new chapter now, functions and graphs. And we're going to start from the coordinate system and the graph. So one of the important things in this chapter is the graph. So let's talk about the coordinate system, Cartesian coordinate system. We have used so far, and it's called Cartesian coordinate systems. We have a horizontal axis, x-axis, and the vertical axis, y-axis. And then you just use the ordered pair to represent the point. Okay. So coordinates of a point on the xy plane is an ordered pair of real numbers a and b. All right. And a is the x coordinate, b is the y coordinate, as you know. In the graph, there's some examples of the points and the coordinates on the plane. For example, at the point 1, 3, you just start from the origin and move 1 unit to the right and up 3 units. So you get that one. And point 3, 1, you just move from the origin 3 units to the right and 1 unit up. Okay, and so on. So these are some points. I guess everybody knows that. Okay, and then we have 2 axes, x and y axis. Now we divide the whole plane into quadrants, and some people still not quite clear which quadrant is which. You start from the upper right, that's quadrant 1, and then you rotate counterclockwise. Okay. So you get quadrant 2 on the left and quadrant 3 down, and then quadrant 4 right, like this. All right. Since we set up a coordinate system, then we can use those coordinates to find the distance and the midpoint of 2 points. So the distance between the 2 points in the graph is, okay, so these 2 points are x1, y1, x2, y2, the coordinates. So the distance between those 2 points is square root of x2 minus x1 squared plus y2 minus y1 squared, and the midpoint of the 2 points in the graph, okay, as shown in the midpoint dot, is the average of the coordinates components of those 2 points. So that's x1 plus x2 over 2, y1 plus y2 over 2. Okay, so some people always get confused about this distance formula and the midpoint. Okay, remember you always get the square root for the distance formula. Okay, and you get the average for the midpoint, and that makes sense. Okay, for example, how do we find the distance and the midpoint between points -4, 3, and 4, 2? So just use the formulas. The distance d will be square root of x2 minus x1 squared plus y2 minus y1 squared. So you can call the first point x1, y1, the second point x2, y2, or vice versa. It really doesn't matter. Okay. So x1 will be -4 and y1 equal to 3. x2 is 4 and y2 is -2. So x2 minus x1 will be just the 4 minus -2, and y2 minus y1 is -2 minus 3. So and at the end you get 4 minus -4, which is 8. So you square 8, and -2 minus 3 is -5. So you square that. So you get 64 plus 25, which is 89. Then you take the root. So that's the distance. And the midpoint is even simpler. You just take the average of those 2 points. So x1 plus x2 over 2, so that's -4 plus 4 over 2. And y1 plus y2 over 2, you get 3 plus -2 over 2. So you get 0 in the first x coordinate and 1/2 in the y coordinate at the end, if you do the simple math addition. All right. Can you stay on this side for a minute? Yes. All right. Just tell me when you're down, you know. So these are simple formulas. Just plug in number and don't mess up x with y. Okay, you just subtract the x2 with the x1. You don't subtract the x2 with y1, so and so forth. You don't add the x1 with y2. You know, the x always goes with the x and y goes with y. That's the thing you should keep in mind. All right. Can we go to the next page? All right. Okay. So the next page is graphing equation. So you got the function or equation. You know, how do you graph it? You plot the points. Okay. For example, if you want to graph the equation y equal to 2x minus 1, you can plot like 5 points here, for example. So you're going to select some values for x and then use that value, plug into the equation to solve for y. So you have some freedom of picking the numbers in x. You don't have to use those numbers in the table. I have it here, but you usually pick up some small numbers that are convenient and easy to compute. So if you pick a -2 for x, then you just plug into the equation, you get the y equal to 2 times x minus 1, x equals -2. So you get 2 times -2 minus 1. So that's -4 minus 1, which is -5. All right. If you pick another number and x equal to -1, then you plug in -1 for x in the equation, you get a y equals 2 times -1 minus 1, and you get -2 minus 1, which is -3. And you can continue to do that for example, picking 0 for x, you plug in 0 for x in the equation, you get a y equal to 0 minus 1, so that's 0 minus 1, that's negative 1. And if you pick x equal to 1, then you plug in 1 for x in the formula, you get the y equal to 2 times 1 minus 1. So that's 2 minus 1, which is 1. And the last, you get you pick 2 for x, and then you can compute y using the formula y equal to 2 times 2 minus 1. So that's 4 minus 1, which is 3. So we got 5 points in here. So 5 ordered pairs that you can plot those points on the graph as shown, on the right. So those are the 5 points here. Then you just connect those 5 points by a straight line. It is a straight line here. All right. Okay. Pretty simple, isn't it? Okay. You can also draw the graph of any other curves, not just the a straight line. Okay. So in this time, this example, you need to graph the equation of a negative x squared plus y equal to 1. But for this particular problem, you would need to rewrite the equation as y equal to x squared plus 1. If you add or move the negative x squared to the right, it becomes positive. So you get y equal to x squared plus 1. And then you can just pick up some number x and plug into the equation to find the y or solve for y. So again, I'm going to pick up negative x to start, negative 2 for x to start. So plug in negative 2 for x, you get y equals negative 2 squared plus 1. But then negative 2 squared is just 4. So 4 plus 1, you get 5. If you plug in another value, negative 1 for x, then you just, plug in the formula with x equal to negative 1. So you get negative 1 squared plus 1 for y. So that's 1 plus 1, so that's 2. And then you pick a 0 for x and plug in formula, we get y equal to 0 squared plus 1, which is 0 plus 1 equal to 1. And then you can pick up 1 to 2. So if x is equal to 1, then what is squared? Anything you square is positive. All right. If you get them negative, are you talking about this equation or are you talking about the numbers? I'm not quite sure about the question. Let me see. What's the question? Okay. It's always possible. Okay. If you multiply a negative number by itself, then you get 2 negatives. That becomes positive, right? Okay. So if x is equal to 1, then you get y equal to 1 squared plus 1. So which is 1 plus 1, that's 2. And then you pick 2 for x, you get the y equal to 2 squared plus 1. And 2 squared is 4, so 4 plus 1 is 5. So you get 5 ordered pairs of points. So you plot on the graph on the right, shown on the right. Then you just connect those points with a smooth curve. Okay. You do not connect the points with the 9 segments. Instead, you need to connect the curve, the points with a smooth curve. Okay, that's one of the mistake people sometimes they make mistakes when they draw the graphs. Okay, you draw a smooth curve. You don't draw 9 segments. All right. Any questions about this thing? This example? Okay, next. Intercepts, okay. What's the intercept? The intercepts are the intersections of the curve with x and y axis. So the intersections with the x-axis are called the x-intercepts or x-intercept if there's only one. And similarly, the intersections of the curve with the y-axis is called the y-intercepts or y-intercept if there's only one. So let's try to find the x and y intercepts of the graph of the function y equal to x squared minus 2x minus 1. So how do you find it without graphing? Okay, first To find the y-intercept, you just set x equal to 0 and solve for y. So in this example, y equal to x squared minus 2x minus 3. So you plug in 0 for x, you get the y equal to 0 squared minus 2 times 0 minus 3. So you get the 0 for the first two terms, and the next is negative 3. So that's the y-intercept as shown in the graph. To find the x-intercept or intercepts, set y equal to 0 and solve for x. All right. And so the equation equal to x squared minus 2x minus 3 again. So you set 0 for y, so you get 0 equals x squared minus 2x minus 3, and solve this equation. And you need to factor the right hand side as x plus 2 times x minus 3. Remember, you need to find two numbers. When you multiply them, you get negative 3. And when you add them, you get negative 2. And those two numbers are 1 and negative 3, right? And then you just set each factor to equal to 0 and solve them. So x plus 1 equal to 0, so you get x equal to negative 1. X minus 3 equal to 0, you get x equal to 3. So there are two x-intercepts as shown in the graph at negative 1 and 3 on the x-axis. All right. Any questions? Okay. Yes. All right. Any other comments or anything? I will try to update the system or this Chrome or whatever you're using the browser. I'll try to update it and see if it works. Okay, yeah. I'll see if it will solve the problem for the audio thing for us. Okay, so let's go to the next page. Okay, let's talk about the circles. So on the graph you can see a circle. It has a center with coordinates HK and a radius R. And then let's talk about the ending point on the circle with the coordinate x and y. Then the equation for the circle is x minus h squared plus y minus k squared equal to r squared. Okay, the r is the radius. And we call this standard form of circles centered at h with radius r. Because from this equation, you can directly read the center radius. Okay, hk and r. They are explicitly reading in the equation. So keep in mind, this is x minus h. It's not plus, and y minus k. Okay. But you can also rewrite this equation x minus h squared plus y minus k squared equal to r squared by following on the left side, and then combine like terms. It's basically the constants, and you're gonna get the J form of a circle. Okay, so that's x squared plus y squared plus x plus y plus c equal to 0 if you do that. All right, and sometimes you are given the standard form, and sometimes you're given the general form, and you're asked to convert the one form to the other. All right, and sometimes you do have to do that by yourself, even it's not asked. All right. Any questions? And so is the radius? No, there is no. The radius is already combined with the other terms in the equation. That's a good question. Okay, that's why you don't have R in here, but it's already absorbed in this equation. It's already combined with the other constants in the equation. Remember, when you try to FOIL the left-hand side, x minus h squared and y minus k squared, then you're going to get a bunch of terms that include constants. And then you move r squared to the right, to the left, and then combine with those, and you get a number c, whatever the number is. So in a general form, you cannot actually read the center hk and the radius r. And then if you want to find the center and the radius from the general form, then you have to rewrite the equation of the circle in standard form. You have to convert it to that form. Okay, that's a good question. I'm going to go to the next page. So let's do one example, maybe, or two. In the first example, we need to find the equation of a circle centered at -2 and it contains the point -1, 2. Okay, so you can see the graph is like the circle is like this, center at -4 and -2, and then contains the point -1, 2. All right, so how do we do the problem? Okay, so we have the center, but we don't have the radius. So if we know both the center and the radius, then we can easily write down the standard equation of the circle, right? So we need to find the radius. We are given the center and a point on the circle. So if you find the distance between the point and the circle, then that will be the radius. Okay, I didn't show the point -1, 2 on the circle, but you can find the radius of the circle by calculating the distance between the center and the endpoint on the circle. Okay, because you know, the distance between the center and the points on the circle is always the radius, right? So so we can use those, you know, the two formulas to find the radius r. So use distance formula r equal to x2 minus x1 squared plus well, 2 minus 1, what 2 minus 1 squared and take the root. So you can let the x1 equal to -4, y1 equal to -2, and x2 equal to -1, y2 equal to 2. So you're going to get the -1 minus -4 squared plus 2 minus -2 squared. Okay, -1 minus -4, so that's -1 plus 4, so that's 3. So you get a 3 squared in the first term under the radical. And 2 minus -2 is just 4 squared. So you get the 3 squared 9 plus 4 squared 16. So that's 25. You take the root, you get a 5. So that's the radius. Now we get the radius. We have already the center. So we can use the standard formula of the circle to write x minus h squared. So that's x minus -4 squared. And plus 1 minus k squared, so 1 minus -2 squared equals r squared, that's 5 squared. So amplify it, so you get the two negatives in both x and y. So you get x plus 4 and y plus 2. So x plus 4 squared plus y plus 2 squared equal to 5 squared. So that'll be the equation of the circle. Or you can write the 25 or 5 squared, okay. So that's the equation of the circle. Any questions for this example? How did you find the h and k? H and k are given in this problem. It says the circle centered -4 and -2. So those are the h and k. H and k are the coordinates of the center. Any other questions? Okay, if you don't have any other questions, let's just go to the next page. All right. Okay, in this example, we need to do the problem in the reverse order. Okay, so find the center and the radius of the circle given by x squared plus y squared minus 6x plus 4y minus 3 equal to 0. So you can see the equation in this case is in the general form. It's not in the standard form, so you cannot read the radius and the center directly from the equation itself. So in order to find the radius of the circle, then you are going to rewrite the general form in the standard form without changing the equation. And to do that, we need to use the technique of completing the square as we did before. I mean, remember when you solve a quadratic equation, you have different methods, and completing square is one of the methods we discussed. But in this case, we need to complete squares for both of x and y instead of just one variable. We have two. So you have to follow some standard procedures or steps. Okay. The first thing you do is just move the -3 to the right and becomes +3. So you have to rearrange the terms of the equation as x squared minus 6x plus y squared plus 4y equal to e. All right, then you use the technique we learned before to rewrite the left-hand side in perfect squares. So what we need to do, we have to write a perfect square for x and a perfect square for y separately. All right. So if you look at the terms with the x, we get the x squared minus 6x. And then we get terms of y squared plus 4y. So you're going to group the terms with the of x and the terms of y separately. And then complete the square for each. Okay, if you still remember what we did before, you're going to divide the coefficient for the linear term by 2. So in the case of x, the linear term is -6x. So the coefficient is -6. You divide that number by 2, that's great. So you get -6 over 2, which is -3, and the squared, you get 9. All right, -3 squared is 9. I do the similar thing for y, so you divide the coefficient for the linear term. So that's 4 over 2, and then you square it. And you get that 2 squared equals 4. All right, and then you add both numbers on the two sides. Okay, so you add 9 in the group for x, and you add a 4 in the group for y. Okay, on the left, you group the two parts on the left. So basically, you need to separate the x and y, as I said. And on the right, you also need to add those numbers at the same time. So you get we already have 3, so you add 9 and the 4. So 3 plus 9 is 12, 12 plus 4. So that's 16. And then you can factor the first group, x squared minus 6, x plus 9, by x minus 3 squared if you do that. And you can also factor y squared plus 4y plus 4x plus 2 squared. All right. And that's easy to do also. So that's the left side. You get the two perfect squares. On the right side, you rewrite this thing as 4 square, and then you compare the standard form of the equation x minus h squared plus y minus k squared equal to r squared. You get the standard hk equals what? 3 and -2. Remember, the standard equation is x minus h squared. And we have x minus 3 squared, so h equal to 3. And then the next term is y minus k squared, and we got the x plus 2 squared. So, y plus 2 squared, I'm sorry, there's a typo in here. So y plus 2 squared, but You know, in the form is 1 minus k. So so you have to rewrite that it has 1 minus negative 2 squared. So that's why k is negative 2. All right, instead of 2. So that's the center, and the value is just 4. Is the number on the right, which is squared. Any questions for this example? So I think this section is relatively simple. You know, if you still remember, the only thing really tricky is completing square. You know, on both variables, and nothing is really challenging. When completing the square, what did you divide to? That's the procedure. Okay, you divide the number by 2. In order to make a perfect square. Remember when we solve quadratic equations, you know, you complete the square, you do the same procedure. You divide the coefficient for the linear term by 2 and square it. That's the standard procedure. And if you do that, you're going to get the perfect square. So the reason for doing this is to get the perfect square for the equation for the variable x and y. And if you don't do that, you're not going to get the perfect square. In this example, if we want to get the x minus 3 squared, then we have to add 9, isn't it? If you want to, you know, have y plus 2 squared, then you need to add 4. Okay, and those are how you get those numbers. Any other questions? Okay, if you don't have any questions, that's so complete the square helps you find the radius. Not just the radius, but also center, you know. You rewrite, remember to find the radius and circle of a center from the general form. You have to rewrite the equation in the standard form. So that's why you need to complete the square, all right? So that you can find h and k. Yes, h and k. You need to find, in this problem, you need to find center, the center and the radius, okay? So the center is h and k, as I said before, you know. But in order to find this h and k and r, you know, you have to rewrite the equation in the standard form, and to do that, you have to complete the square and you know, rewrite everything in the completed squares. Any other questions? If you don't have any more questions, I guess then we are done with this section. I guess we have 7 more minutes. So I guess we can start a new section a little bit, maybe. So let me just get the next section. So let's talk about 2.2. So I'm still uploading the slides in 2.2. So now I got that one. Okay, in section 2, we're going to talk about the functions. So in 2.1, we just talk about the coordinate systems, okay, and the graphing, basically. In this section we're going to talk about the functions in the more general sense. So we're going to start from the concept of relations. Okay, what is a relation? Any set of order pairs is a relation, all right, or relations. So if you got a set of order pairs, okay, that's called a relation. So in terms of the graphing, that means you have a set of points. Okay, so any set of points is a relation, all right? So for example, the set of all the pairs, 0, 0, 116, 264, 25, 100, that's a relation, okay? We have 4 ordered pairs, all right? And they represent the 4 points on the graph, okay? And another example is this equation d equal to 16 squared is a relation where t is greater than or equal to 0 and d is also greater than or equal to 0. Okay, so this time the relation is represented by the equation instead of listed ordered pairs. You can use different representations for the set of ordered pairs, and you can use the equation. All right. Essentially, the equation of d equal to 16 t squared represents the ordered pairs. So, t and d, if you say t as the first coordinate and d as the second coordinate, then you get a set of ordered pairs with td, with all positive and the 0 values for both t and d. Okay, so that set includes infinitely many pairs or points if you draw it, and we know that's actually a part of the parabola. Okay, the curve. So you can also use a curve to represent the relation, like in the next example. So we got the red line, and that is also a relation because it is a set of all the pairs. In graph, it's just a set of points, and it's a set of points includes infinitely many points on the curve, in the red curve in the graph. Okay, so then the function is a little bit from the relation. Okay, function is a special type of relation. It is a relation in which no two ordered pairs have the same first coordinate, different second coordinates. So in other words, for any value for f x, in a function, you can only have one value for y corresponding to that x. So you cannot have two ordered pairs with the same x and different y's. Any x only results in one y value. That's what it says. All right. So the function notation can be y equal to f of x. So that means y is a function of x, and f is basically a notation for the rule. Okay, you define the function. The rule is called the f. And x is also called the independent variable, and y is called dependent variable because basically you can choose the x freely, but the y has to be calculated from x based on the rule of f. So for example, f equal to x squared minus 1 is a function because first it is relation because it's ordered pair. You can rewrite the function as f equal to x squared minus 1 or y equal to x squared minus 1. Okay, so that's an ordered pair of x, y. And in fact, if you plug in one value for x, you only get one value for y. Okay, you will not get two values for the y if you plug in any value of x. You plug in 0 for x, you get 0 squared minus 1, that's negative 1. you plug in 3 for x, you get 3 squared minus 1 equal to 9 minus 1, which is 8. So that's also y as one value for y. Okay. Or if you plug in negative 2 for x, you get the negative 2 squared equal to 4 minus 1 equals 3. So you still get one value for y. So that is a function. Okay. I guess I'm not going to continue with the next example. It takes a little time to explain this, and people usually are not quite familiar with these kind of things at this stage. So let me just stop here, and I'm going to take the rule now, and then you can stay here to ask me questions if you have any. So don't leave, before I take the rule. All right. I got the rule now, so you can leave. And with people who want to stay here, ask me questions, you can do so. If you want to call me, you think that's more convenient, just call my phone number, my cell number. Yeah, it looks like the audio on your side is not working. Okay. So have a good weekend. Do the access code set up for your account and so that you can take the test in next week, and also do a little review to prepare do this group start, for example, to prepare the test. Okay, that's a good strategy. I cannot hear any word voice still. I don't know why they have not fixed them. I'll try to update Chrome or the software a little bit to see if it works. So I'm going to stop the recording now.